Now let's talk about indexing, and I want to give you some basics in a video entitled Understanding Indexing, because we're starting to move into a few areas here in the course, and there's only one way to describe this, and that is when you start to work with data warehouses in SQL Server, you're going to be more adept at this based on how broad your understanding of how SQL Server works, the tools that you have at your disposal as a database designer. All those things kind of fit together. So the more you understand overall about SQL Server, the better you're going to be at data warehousing. And in this video, I want to talk about how indexing affects how data is both stored and how it's managed in SQL Server. And obviously, as a result of both how it's stored and managed, how easily and how efficiently it is queried back out for our reporting, which is generally what we're using our data warehouse to provide. Now that you have four main indexing options in SQL Server 2012, and I'm going to list them here and then I'll talk about them just a little bit. Now keep in mind on every one of these, if you're not very familiar and comfortable with these, you should go out and read in books online or go out to Microsoft's website and read about each one of these, because you will see them on the exam. But even more important than that is you're going to need to understand these in real life, because it's very hard to say that on every data warehouse you should put this kind of index. You really need to understand what these are, how they work, to understand if it'll work or if it's helped or hurt your particular data warehouse. And then there's the old thing that a lot of times in a data warehouse environment, we just try an index and see how it does. If it's better, great, we keep it and we look like database gurus. If it's not, we just quietly take it off and don't mention it. So anyway, first up is the clustered index, and then we have a non-clustered index. Then we can use a filtered non-clustered index and a column store index. Now let's take a look at each one of these four types of index. First of all, the clustered index. The clustered index determines the physical storage order of the data. In other words, it determines how the data is actually ordered in the disk file when you're storing it in the database. And as a result, there can only be one clustered index on a table, because since we can only store the data in one order, then we can kind of shoot that bullet one time, and we can determine what's going to be our clustered index. Now, a non-clustered index does the same thing almost that a clustered index does. It sorts data in a column or in a group of columns, but it doesn't actually change the order of the data in the table. What it does is it stores pointers to the actual data rows, and if you really want to think about it, it's kind of like the index at the back of the book. It tells SQL Server, hey, if this table was in order based on this non-clustered index, this particular row right here would be number 1. This one way up here would be number 2, and so forth. And so we can kind of do some searches within non-clustered indexes to speed up our data extractions. Now, you can have up to 999 non-clustered indexes on a table, but let me warn you, every non-clustered index that you put on a table has to maintain these pointers, and then every time we put new data in, the pointers have to be renumbered and rearranged. So the more non-clustered indexes you have, the faster you can pull data out of your table. However, it starts to get a whole lot slower and less efficient for adding data to the table or making changes to it. Now, in a data warehouse environment, oftentimes we're not making that many changes, and we certainly aren't doing very many updates, so you may be able to get away with more non-clustered indexes. You'll just have to test them. And again, these will slow down data management. Now, a filtered non-clustered index allows you to create a non-clustered index on a column, but let's say you have a column where part of the values are very similar, and then part of the values in that column are very unique. You can create a non-clustered index just on that subset of very unique values and not waste the energy or the effort or the efficiency of creating a non-clustered index on all those very similar pieces of data. So a non-clustered filtered is just a non-clustered index, and you can choose a subset of values in a column. It's like a partial column non-clustered index. Then a column store index. This one's very interesting. This is really just a non-clustered index placed on a single column with one really cool caveat. This column then gets stored and searched separately from the data row. Now what this means is if we have a query that's querying only from one column, and that column has a column store index, then SQL reads that column as if it was a table, and that's all it ever reads. It never has to go out to the individual rows. It just reads through that one column. Again, read more about this, but column store indexes can be huge in data warehouses when we're pulling from single columns, and you can composite these, but you'll just have to go look at that. Adding a column store index, however, will make that column read only. And that is a limitation, but again, in data warehouses, we're not doing a whole lot of updates. Now, here's another little caveat I want to throw at you right quick before I end the video here. SQL Server stores data in its tables in two forms. In a heap, and that means the data is stored in whatever order we add it. There are no indexes, and so anytime your data is stored on the heap, it's going to be very fast to load because it doesn't have to get in any particular order, but it's going to be kind of slow to query. All your new rows get added to the bottom. A balanced tree or a B tree organization is where the data is ordered based on the clustered index key. And so the clustered index causes it to be in a certain order. So that's just a little background on indexing in SQL Server. I hope this will help you kind of navigate your way through some of the confusion with indexing and those questions on the exam.